So as you can see in the IME 450 class, we have like regards to operations, which the second one depends on the first one's data and everything. So we kind of need a dedicated tool to act as a fixture to help manufacture the second op, but so far we don't have that. So the class project is to build a fixture that locates and reduces error to scrap and rework and increase production time and reduces costs. So the customer needs us to build a fixture like this, which we did with a minimum safety factor of 3.0 that is easy to load, lock and load, and it fits with the Huang tombstone, which is right here, and I can demonstrate how it's used. It can easily be assembled like this, screwed on, then after that, and imagine this is not machined perfectly, right? It has a stock, it'll come in easily and fit everything, locates off the datums, tighten with the clamps, and after that you're all good and ready to manufacture off a datum locator here, so it's all self-contained, and also uses stock parts from MIDI-byte and also other regulated parts, so it minimizes our own tooling costs and just works compatibly to mass manufacture and repair if it ever goes broken or anything like that. So yeah, it's great.
The main constraints were that the part has to be located and clamped by a Wyhs, and as well it must mount to a tombstone as seen here in the following picture. Then as well it must hold the mighty beast and the locating rail, which were regular parts as mentioned already by Nathan. And criteria for success were that the part locates repeatable of operation 1, which is producing the fixture plate, that the clamping meets a safety factor of 3.0, there is no cam collision, and it fits one side of the cutter, which you can see here in the technical drawing. The fixture design process included the calculations and the FEE analysis. We calculated a minimum clamping force of 195.07 pounds, which is definitely enough since the FEE analysis was done with 800 pounds and the part is not breaking. So we are safe. And actually we could have only used one Mighty Bee, but we still went ahead with 2 Mighty Bees.
The fixture design documentation included all the technical drawings. Our design goal was to minimize the part, but still with respect to the constraints, and go as simple as possible with the design. Since a complicated design means more tools, more machining time, and also overall more cost, we used the locating rails and the pin to locate the box cutter and to clamp it with the Mighty Bees. Here you can see the exploded view and all the parts that were used, like the pins, the locating rails, the Mighty Bees, and also the overall fixture plate.
First we got a aluminium block, which we cut roughly to a size to 3.5 inches. And after that, we precisely cut it to its width with this machine.
Showing off the cam right now, I'll first show off the stock simulation to see how it will be machined. And as you can see, there's no collisions, and that's all respective information about tooling. After that, I will show all tool paths. As you can see, covers all the features we machined. And all the blue lines represents the movement of the tool, and yellow lines meaning the retract and movement. It all looks just fine. And
with the cam available, we got the CNC operation planning, which gave us roughly about 50 minutes of cycle time, and we could calculate our tooling costs, which was about $416, and we roughly estimated the costs from the Mighty Bees and the locating rails with some resources out of the internet. After all this work, we were finally able to CNC our part. Here you can see the multiple steps it requires to create the fixture plate, like drilling the holes, creating the rough cut, and also making the clamping holes. Our final result included, unfortunately, an error. You can see it in the bottom right, but we were able to fix the problem.
Why our part? Even though we had struggles with our first part, we were able to create a better version where all the problems were fixed. We also modeled and machined the whole part in less than 4 hours, so we now have experience for any changes that might happen in the future.